All right, so let's talk about the suggested friends problem. All right, so the idea is you're building a social network from scratch. It's for your school, and you know that people are kind of in cliques, but you want them to become friends within the cliques. You want to drive graphs towards K completion. So, very similar to our other graph, we're using a dictionary to hold track of all of the nodes. We're calling them members because they're people instead of nodes. And then we'll still have the add edge function here. I've also included the subgraph problem for reference so you can kind of see what it looks like to traverse the graph. Okay, so here's the actual problem. We are building a friendship suggester. So when you look at all the different friendships, and I've separated them here by their sort of groupings, right? You can see that you actually have three distinct subgraphs within this graph. And so a graph is a really ideal structure for showing relationships between people because they're most often a graph. So let's look at a visualization of this. Yeah. So we've got this first graph here. This graph is the largest graph, and it's disconnected from these other two graphs, right? Alice is friends with Dave and Carol and Bob. Eve is friends with Bob and Faith. Grace is only friends with Faith. And Dave is only friends with Alice, Bob, and Carol and Faith. So he's like the most connected person. Alice is also fairly connected because she's connected to Bob, Dave, Carol, and Eve. So we've got some fairly connected people in this group, but if you look at Carol or Grace, they're not very connected. Faith is friends with Dave, Eve, and Grace, but she's not connected with Alice or Bob. And so we want our friendship suggester to suggest friends who will have the most friendships in common. You might recognize this from Facebook's actual friend suggester. It tells you how many friendships you have in common with a person. So, how do we determine who actually needs to be friends? Well, we probably want Faith to become friends with both Alice and Bob because Faith is friends with Eve, who's friends with Alice and Bob. Uh, Faith is also friends with Dave, who's friends with Alice and Bob. Faith is friends with Dave and Eve, and Dave is friends with Carol, but Carol shares the fewest connections with Faith's friends already. If you look at Eve, she's not friends with Carol, and so you can see like there's fewer connections between Faith and Carol, fewer second degree connections. So that's what we're really looking for. We're kind of doing a breadth first search, and what we want to find is who of my friends are the most connected to me. Who of my friends share the most common friends? We can see this better in this smaller graph here. So Robert, being friends with both Xavier and Quill, is similar to Zed, who is also friends with Xavier and Quill. Xavier and Quill are friends together. So who is the most likely connection to make? Well, Zed and Robert should become friends because they share common friends. They share two common friends. If you look at this other graph here, there's not any suggestions that we can make between Heidi, Niaj, Ivan, and Trent because they're all already friends and they don't have any friends in common that they aren't already friends with. So this group being K complete is not a very good, it doesn't have any common friends that we can actually suggest. So if you look at the examples of what we should return, if we pass in Faith, we should get Alice and Bob because Alice and Bob have the most common friendships. If we pass in Robert, we should get Zed and vice versa. If we pass in Ivan or anybody from this K-complete group, we should get an empty set because there's no one to suggest. So how will we set up the solution for this? Well, we know how to get each one of the members friends, right? So my friends is me, is self.members. And this is essentially self.nodes or self.vertices. This is all the elements in our social graph class. And so if we pass in me, this is all of my friends. Now, I'm going to be frequently checking this my friends thing, so I suggest you set it up as a set. In fact, I suggest you use a lot of sets here. Now, if you look again at the image, right, there are going to be people who are more suitable than others. We don't want to just suggest my friends, like indiscriminately. For example, if I wanted to suggest friends for Eve, Grace is not a great suggestion, but Carol is a great suggestion because Carol shares my friendship with Alice. And Carol shares, well, I think actually Dave is the best suggestion. Yeah. Dave shares my friendship with Alice, and Dave shares my friendship with Faith, and Dave shares my friendship with Bob. So I have 3 friends in common with Dave. Dave is the best one. Carol only shares my friendship with Alice, and Grace only shares my friendship with Faith. So they're less good than Dave because I have so many friends in common with Dave if I'm Grace, or I mean, if I'm Eve. But yeah, I mean, it's not the same for each person, right? Carol, if Carol wants to have a friend, Faith is pretty good because Faith shares my connection with Dave. But Bob is better because Bob shares a connection with Dave and Alice. And so that's 2. Eve is pretty good too because, well, no, let's see. Yeah, Eve is actually pretty terrible. Eve doesn't share a connection with Dave or Alice, my 2 main friends, as Carol. So you have to kind of think what we've got is a number, we've got kind of a ranking of similarity that we've got to also determine. And so what I'm going to do is keep track of this as potentials. And then I'm actually going to call this a hash map. And what I'm going to store in here is how many friends we have in common. That's the key. So what I'm going to do, and I'm not going to solve this fully, is I'm going to loop over all my friends, check to make sure they aren't already, and then loop over all of their friends. Check to make sure they aren't me, and also that I am not friends with them. So I don't want to include my people who are already my friends, and I don't want to include myself in this. And then what I want to do is determine how many friends we have in common. Store in the potentials buckets by their common friendship count. I highly recommend you look into having a set dot intersection here, because that will essentially, like, if you use a set, their friends, right? If we look at like a potential friend, friends, and we use the intersection of my friends, then we can easily get that count. So this is a line of Python that you might use. Potential friends, the intersection of that and my friends, that'll get you that count. So in the next video, we'll translate this Python into pseudocode, but try to solve this on your own before you go there. All right, thanks.